Now this microphone is good enough to pick up, the door opening and closing and all the noise from the door. You will see, when you guys listen to it, you will actually hear, at the beginning of a class, the door opens, it closes, footsteps, the door opens again. Okay, so we are done with the syllabus. Very good. Okay, but instead of giving you a hard copy of the syllabus, I don't. Okay, I give you a link to the syllabus. But in order to confirm that people have access to the syllabus, I want everyone to participate in this activity here. This is called a choice activity. It has a little question mark here as the icon. So when you click it, you will see what you're supposed to do. You have to answer this one little question. The choice activity is like signing a form to indicate that you know where to find the syllabus and that you have read the syllabus. It's an acknowledgement that you have found and read the syllabus. So I want you guys to pick one of these two choices and turn in your answer. I think the answer is obvious. Okay, and that's what you have to do by Sunday this week. So I'm imagining that most people can get it done on Sunday, by Sunday, sometime. Okay. And since you have a laptop with you, I think you're done already. But before you click, I do want to make sure that you have to read the syllabus first. Okay, I kind of went over the syllabus line by line, but you should still read it first. So that's your activity, and that's why in the upcoming events, there's a little reminder for you to participate in the syllabus choice activity. But you can click this one here, but it won't help. You actually have to click the link next to the question mark to get into the activity itself. There's a general forum for this class. The general forum is for you guys to talk about stuff. Okay, just any topic you want. You can post it in the general forum as long as it is, related to this class and it is courteous and observe all the common etiquette of participating in a forum. In this class, okay, let's go to the first homework assignment. What? Homework assignment already? We haven't even talked about the first thing about programming. Yes, homework already. So your first homework is this homework here. The homeworks have, there are several ways to find your homework. The first one is to look at the upcoming events. When you see a hand holding a piece of paper, that means it's an assignment. So you can locate your assignments, that is to be due under upcoming events. You can go to topic 1, and here's the same homework assignment. You can also click assignments under activities, and it will also list all the homework assignments that are assigned at this point. So there are at least 3 ways to find your homework assignments. And any one of these 3 ways is just as good. So what I'll do is I will click the homework assignment, and before that I will switch to a student role. So what I see will be exactly what you will be seeing. Okay, so now I switch to a student role, which means this is exactly what you should see when you log in. And you can click this link, or you can click this link down here. So I'll just go ahead and click this link. One thing I use a lot in Firefox is the use of tabs. Because if you use a right click and then select open link in new tab, it will keep the page, it will keep the original page, and it will open up a new tab for the homework assignment. So this way you can switch between back and forth the 2 pages more easily. Okay, this is your homework assignment, which is a lot of reading, but it's not that important. What this class will need at some point is the use of a spreadsheet program. Okay, and there are many spreadsheet programs out there. I do not want to force people to have to buy Microsoft Office just to get to Excel. How many people do not have Excel installed on a computer? Okay, and how much is Office? 79 for students. Yes, but it does it chews up a lot of disk space, and it is not portable. Okay, just because you have Excel installed on your computer does not guarantee that Excel will be installed, let's say, on a computer in the library. or on the computer that you have access to, in the lobby of a hotel, and so on and so forth. So what I want to do is to use OpenOffice Calc instead as the official spreadsheet program for this class. Okay, now this means that you have to use OpenOffice Calc instead of Excel in this class. Even if you have Excel already installed, use Calc instead. Okay, I know it sounds kind of sounds like a dictator, but this really is necessary to do what I need to do. Okay, and in this case, your homework assignments and the exams will be done using OpenOffice Calc. But I don't have OpenOffice Calc or OpenOffice installed on my computer. What should I do? There are two ways to install OpenOffice, which includes Calc as the spreadsheet program. The first way to install it normally on the computer. Now I can right-click and go to this link here. This brings me to OpenOffice.org, the download part of it, and I bring you all the way to the download page. And depending on your operating system, it will give you the right file to download. If you go to this web page from a Windows machine, it will give you an executable to install the program. If you go to here from a Macintosh computer, it will give you a DNG file to install the program. If you go to here from a Linux box, it will give you the necessary file to install it in a Linux environment. Yep.
So what if you run? I mean, what if you run XP on your home computer, but then there's Windows 7 on the computers here? If you install it, can you use it across those, or even worse?
I am glad that you asked that question. I will answer that in a moment. Okay, so in using this method, you cannot. Using this method, you can only use OpenOffice on the machine that you install OpenOffice onto. So it will change the registry, it will install the DLLs and whatnot, so it is specific to the machine that you installed it to. Okay. The good thing about this approach is the installed version will be efficient. I mean, you can bring it up pretty quickly because it's on the hard drive. But as you pointed out, what if you want to use OpenOffice on different machines? The one at home, the one over here in the library, the one in 152, room 152, the ones in the LRC, and so on and so forth. Then you want the second option. The second option is to get a thumb drive of 4 GB or more capacity and install the portable version of OpenOffice. Yep.
What brand do you recommend
for the flash drive? Not the ones that I got from Fry's, and it's the brand name is Patriot, so avoid Patriot. Okay, just about anything is good. My personal recommendation is not to buy a thumb drive. My recommendation is to buy an SD card and then use a card reader to act as your thumb drive. Now, the reason why I recommend that route is because with SD cards, they can guarantee the speed. Okay, when you buy an SD card, they come in different classes. Class 4 means 4 megabytes per second. Class 6 means 6 megabytes per second, and they go faster these days. Even they go way beyond 6 megabytes per second. So now you can actually look at the prices of SD cards and pick the right balance between cost and speed. Okay, when they come up with faster ones, or when they come up with higher capacity ones, you can keep the old one for something else, but you can always upgrade to a new SD card. So that's the route that I recommend, is to use a flash medium and then plus a flash reader, as a combination. If you want something that's really, really fast, SD cards are not as fast as compact flash cards. So when you go to Fry's or some other places, look for compact flash media, because they are usually faster than SD.
They're a little bulkier though, aren't
They are slightly bulkier, but they are still small enough that you can put it in your pocket. It's just that with a compact flash card, you can't really use it on a whole lot of cameras anymore. Most cameras have switched from compact flash to SD cards. But if you want speed, compact flash is faster. Okay, that's a good question. And that's why personally, I only use SD cards and compact flash cards. Like right now, the whole thing, this entire operating system is running from an SD card plus a CF, a compact flash card. Okay. Now, this portable version can be installed without administrative rights. In other words, all you have to do is to plug in your thumb drive, okay, or your flash reader card or whatever, and download the executable. When you run the executable, it does not require administrative rights. When you install the program, you can install it not on the C drive, but on your thumb drive. Okay, so now you have OpenOffice installed on the thumb drive, which makes it portable. Okay. So once you have it installed on a thumb drive or an external hard disk, that means you can now take your thumb drive to any computer running Windows. Well, except for Windows 95 and 98. Okay, you can plug it into any machines running 2000 maybe, 2000, 2003, XP, 7, Vista, and so on. And now you have access to OpenOffice instantly. Okay, that's the advantage of the portable version of OpenOffice. So the link to get OpenOffice Portable is here. It belongs to portableapps.com, which has a lot of different application programs that are also portable. For those of you who are adventurous, you can go to Applications and take a look at their other choices as well. The other program that I recommend you install using a portable version is Firefox. And you might ask, but Firefox, most computers have Firefox installed already. Why do I want a portable version of it? Well, don't you want to carry your bookmarks with you, the settings, the plugins, and so on? If you don't use a portable version of Firefox, then the plugins, the settings, the options will be local to the machine that Firefox is installed onto. You cannot carry with you easily. If you use the portable version of Firefox, guess what? The bookmarks will be on your thumb drive, the plugins will be on the thumb drive, and your configuration will be on the thumb drive as well. Okay, and that can come in pretty handy depending on how many plugins you install into Firefox. And I have some good plugins to stop advertisements and stuff like that, and it comes in really handy that I can access that all the time. Yep.
Can you have them sync between your local computer and SD card?
Yeah.
There has to be a way, but I'm not sure how
There's
to do it.
some add-ons to do that.
Okay.
Firefox, I don't know about other browsers, but Firefox at least has a couple add-ons to do that.
Okay. I think with Firefox, you can always do it the long way, like manually, moving the files around and changing the configuration files. You can always do that. It's just that it's more troublesome to have to do it that way. But there are plugins that can do that too. Okay, so download this one, and you might ask, but how much space should I use, on the thumb drive? Well, it says right here it's 92. Well, most of you cannot see it because of the contrast, and it's also a smaller font. It says right here 92 megabytes to download. Once it is installed, it will take up 230 megabytes. Basically a quarter of a gigabyte. Do you think that would be okay?
Oh yeah.
Okay.
That's pretty good for a portable Office application. Now, in the Office applications that are portable, you can do whatever you want on them, right? I mean, it's like having that. For Word, or does it have Word in it too?
It has a word processor. They don't call it Word, they call it Writer.
Yeah.
This is a full installation, and which means if you move down a little bit here, I'm not sure whether they listed. Okay, this screenshot has all the applications, and you guys cannot see it, but I'll just read it here. It has a word processor, a presentation software like PowerPoint. It has its own database program, kind of like Access, but not nearly as polished. It has a spreadsheet program, okay, it's kind of like Excel. Has a hand drawing program. Does Microsoft has something like that in their Office suite?
Yeah, Paint.
No, this is not Paint. This is more like Illustrator. It's a freehand type of drawing program. You can use it to draw like org charts, flow charts, and stuff like that. Yeah, it's kind of like Visio, but not as rich in terms of features. But for simple pictures and charts and whatnot, it can do it. So this is all included, with that 230 megabytes installed. which is not too bad, not a really bad deal. And it's all free. Okay, this is all free and it is open source, which means if you find it useful and you know someone else who might be able to use something like this, have them download it. Share your executable. Because it's open source, you are free to redistribute the files. Yep.
I'm using LibreOffice, which is a fork of OpenOffice. Is that
Yep.
all right?
Yeah, that will be fine. Yep. Now, have they moved away from the main branch at this point, or are they still pretty much, just a relabeled version of OpenOffice?
I still have one of the earlier versions, so they're closer to the main branch.
Okay.
I haven't checked it out lately. in
I
the
see.
Downloads.
Mm.
So they should be pretty close either way. They just had issues with what the
Oracle?
who acquired
Yeah, Oracle.
Oracle. They were having issues with Oracle, so they split.
Yeah. Yeah, basically, if you look at, so what he is talking about is, OpenOffice was a product. It was derived from Star Office. Star Office was a product that was made by Sun Microsystems. Sun Microsystems was purchased and absorbed by Oracle. And Oracle does not really have a good track record of open source stuff or working well with other people or playing nice with other people. So after they acquired Sun, a lot of people left the company. The entire Java team left the company. Okay, the MySQL team left the company, and the OpenOffice team, or some of those people, also left the company. But OpenOffice is now a product of Oracle because it was a product from Sun, and since Oracle bought Sun, so now it is under Oracle. And a lot of people have doubts about Oracle's intention to continue open source support of OpenOffice. So these people went out and they started a new project called LibreOffice. Is it Libre?
Yeah.
Yeah, LibreOffice, which is just like OpenOffice, except it is maintained by people who are outside of the Oracle organization. Okay, you can look at Oracle as Nazi Germany, and OpenOffice is Austria or Denmark. It's more like Denmark. Yeah, yeah. Mm-hmm. I have a lot of respect, to the Danes during World War II. So anyway, you can do both. Okay, if you want efficiency when you're home, install the version that you can install, but that will require administrative rights. But you can also have the second option, put it onto a USB thumb drive in case you need to use OpenOffice on a machine that does not have OpenOffice installed on the hard drive. Okay, so go with both. I mean, it doesn't take up that much space on your hard drive. Why not? The only thing you have to be kind of know about is the installation can be quite slow. It can take up to an hour to install the portable version. It has to do with the flash drive, the thumb drives. A lot of thumb drives are very slow when you write to the drive. The write speed can be down to 1 or 2 megabytes per second. And when you install OpenOffice Portable, there's a lot of write operations. And as a result, it can take a long time. Okay, once it is installed, running it is not nearly as bad. Okay, any questions at this point? No questions? Yep.
Trying to download the file on the homework. I asked me for an enrollment key. Will that be sent to email soon?
Say it again?
I was asked to give an enrollment key after trying to download the file in the homework. You want us to mess with it?
Oh, that's because I copied this from another class. Okay, I'll fix that. Sorry about that. Okay. Yep, go ahead.
You said the mobile or the website? We were supposed to receive an email that links us to.
Yes.
When was that sent?
It was sent this morning at about 8:10, 8:11 or so. So if you check your mail now, you should be able to see it. It will say it's coming from someprofs.org about a class that you enroll in the Los Rios district. Okay, so I will have to fix this link, because it's linked to the file from another class, and so that's why you cannot access it, because you're not taking the other class as well. So I will have to fix that link to point it back to this class. Okay, so let me fix that first, okay, because I don't want to. If I have to fix it, yeah, I have to get out of here anyway, because otherwise I can't fix it. Yep, go ahead.
Where'd you say that the Moodle email's coming from?
It will be coming from someprofs.org.
Oh, okay.
Yep, if you look at the origin, it will be coming from someprofs.org.
So it's not spam.
It's not spam. Well, it gives you all the information that you need to log in. It does not ask you for any information. So it should be fairly safe. Let's see. I'm just going to change that part to make sure that you guys can access the file first. Okay, this document. Change the link. There we go. Should be changed now. So let me save it again. Display at the same time. Okay. Do you want to check it again? You should be able to open it now. So with this homework assignment, all you have to do is to download, quote unquote, this document, which is a hyperlink. If you click it, depending on your browser, you may see this screen, you may see you can only save, or it will open it automatically. If you open it from a browser, it will be open in a read-only mode. So I'll just go ahead and do it this way. I'll open it from inside the browser, and it will bring up OpenOffice automatically because it recognizes the extension or the file type. Did it work?
It works.
Okay, excellent. And in my case, I'm running the entire operating system out of an SD card, and that's why it is, also kind of slow compared to from a hard drive. How many people have noticed that I have not been using Windows?
Yeah, I did. I noticed that right off the bat.
Okay. Yeah, this is Linux on an SD card. The entire distribution is 2 gigabytes. Yep.
Do you have any of the directories on the compact flash card?
Sorry?
Do you have any of the directories on the compact flash card, like user, var, the swap file, or anything?
Yes.
Okay.
Yep. This is what they call a COW, C-O-W, a COW approach. COW stands for copy on write. In other words, everything is running from the SD. The SD is a read-only device, but when I save something, it will save it to my compact flash card.
Okay. Cool.
Mm-hmm. Yeah, it's kind of cool. Okay, so this is the file that was linked from the homework assignment, and let me bump up the font size here. It's a spreadsheet program. It's a spreadsheet document, and you can also see from the title bar here, it is read-only at this point. That means you cannot make any changes to the document. The homework tells you that you have to go to sheet 2 of the spreadsheet, add your name as cell A1, save the file, and then upload it. So I cannot do it. I can switch to sheet 2 without any problems, but when I try to type something, it complains that this is in read-only mode. And you will encounter the same problem if you open up the document from inside a browser. It's a very easy problem to fix. All you have to do is to go to File, go to Save As, pick a place that you can remember, okay? So I would go to User, Documents, or whatever. It doesn't matter where I save it. So let me find Documents. And you can save it, just using the default name is fine. There's no specific requirement of the file name. You can keep the original file name. Save. And once you save, you can see the read-only part is gone. So that means, this document can be edited, at this point. So I would put my name into A1. Okay. sheets. Oh, there we go. And save the document. Now, before you turn it in, it is a good habit. It's not needed, but it's a good habit to close the document before you turn in the file. Just in case there's any changes that have not been saved yet to the document, it's always safer to save and close the document before you turn in the file. Now that I have closed the file, I will go back to the homework assignment. Scroll all the way to the end, but now I'm a professor, so I have to switch my role back to a student to see that link. Okay, sorry about that. Okay, so now, because it is, it's available in the future. That's why I cannot see the link. My bad. I thought it adjusted the time and dates, but not the way I wanted it. So I have to change that again. Sorry about the confusion. So I have to make it available today. Today is the 21st. I will make it due in a week. Do you guys think you can get this done in a week or so?
Yeah. Yeah, that's downloading it.
Well, you first have to look up your name and all that stuff, It takes time.
You just said you want 2,000. I think you just said you want 2,000.
Oh, did I set it to 2,000?
Yeah.
Oh.
Yeah.
No?
No, it's due 2011.
Yeah, it's right. Okay. It's okay. It's good to double check. Okay, so now I switch back to a student role, go back into the homework assignment, and the link is here. Okay, so when you scroll all the way to the bottom of the screen, it will tell you when it is due. Okay, available from is not usually an issue. I will make it available as soon as possible, but the due date is the important part. So in this case, the due date is the 28th, which is next Friday, and the time is 8 a.m., right before the class. Okay. And that's the typical format. I always make my homework assignments due on the morning right before the class, so that I can talk about the solution during the class that way. So to turn it in, I click on this bar here. It opens up a dialog box for me to find the file, and it is under Documents, and the file name is cisp300 which stands for OpenOffice. Double click it. I'm not done yet. Okay, don't close the browser. This is only specifying where is the file that you want to upload, but it has not been uploaded yet. So the next thing you have to do is to click the Upload this file button, and make sure you see the confirmation file uploaded successfully. Now, if you click Continue, Moodle does let you download the same file that you have uploaded. Okay, just to confirm, you can double check and make sure that's the file that you want to upload. Which means if you scroll all the way to the bottom of the screen, it shows you that this file is now turned in. If you find that this is not the right file to turn in, you can actually turn it in again. You can resubmit as many times as you want before the due date. Okay. So when it is actual time to do the homework assignments, it means that you can submit a partial solution, and you can use Moodle to store your partial solution. You can download it back, work on it some more, re-upload it, and so on and so forth. Are there any questions about doing this homework assignment? Okay. Think you will need a week to do it?
Yes.
Yeah.
Okay.
When you submit it multiple times, you're going to see all of them? It doesn't automatically wipe out the previous ones?
It does.
It does.
Yeah, it does wipe out the previous one. In other words, it will only keep the last file that you upload. Yep, go ahead.
This question is not about the assignment, about OpenOffice in general. If you use the text document from OpenOffice, can you open it in Microsoft Word or?
It depends on the version of Microsoft Word, but I believe if you have the latest version, like 2010, or if you have if you have a patch on the 2007 Microsoft Word, yes, you can open it too. But when you do homework assignments for this class, you have to use OpenOffice Calc to do it. And I can tell, who is not using OpenOffice Calc to do it, because when Microsoft Excel saves an ODS file, it leaves, its own fingerprint behind, so I can actually tell. Okay, are there any other questions about this particular assignment or how to set up OpenOffice? No questions?
I have a question.
Yes?
Can you run OpenOffice on like an Android?
No, the Android does not have enough resources to run OpenOffice. Yeah, you cannot do it on an Android. You can do it from a netbook. I had a netbook and it was able to run OpenOffice without problems. Okay, any other questions? No other questions? Okay, so we'll go ahead and start on the main topics. Okay, the first part, which is developers and algorithms, is just an introduction to algorithms, what they are, why do we need it, and also the people who need to have access or have to study algorithms, which are the developers. So that's why we have this little slide here, or this little document. Every document that I make is called a module, because I try to make my notes modular. So each one is basically what I call a module. Yeah, my compact flash card is really acting up, and that's why, it's kind of stuck sometimes. It looks like it's stuck. I want to display this frame on its own. There we go. Okay. The first slide, or the first section, talks about computers and software. Electronic digital computers have improved dramatically over a short period of about 50 years. 50 years doesn't sound like a lot of time, but if you think about it, the advances that people have made on electronic computers over the past 50 years is phenomenal compared to other technologies. When was the internal combustion engine invented?
21? Was it 1921?
1921? Okay. And we have seen a lot of changes with internal combustion engines, but to use double the horsepower, given the same energy consumption every 18 months with cars? No. They might double every decade or so. Okay, given the same miles per gallon, the available horsepower may double every decade or every 2 decades or so. Okay, but with computers, we double the processing speed every 18 months. This is called the Moore's Law. Okay, have you guys heard of it? The Moore's Law? M-O-O-R-E, Moore. Okay? Well, that is quite interesting because how many times would it have doubled over a period of 50 years? So 50 years times 12 months, divide this number by 18. Okay? So approximately, what is it? So it's 50 times 2/3.
It's like 30 times approximately.
So about 33. Okay? Now, 33 is not a big number. 33 times. So a computer today, has 33 times the processing power of a computer that is 50 years ago. That doesn't sound right because it was wrong. It is 2 to the power of 33. Okay? So we are talking about power here because every 18 months it doubles. Okay? So every 36 months it quadruples. Okay? Every 48 months, 36 plus 18 is what? 54 months. So every 54 months, it multiplies by 8, and so on. So after 33 18 months, this number is huge. Okay, this number is approximately 8 billion. Okay, so if Moore's law is the law to predict processor efficiency, then a computer today that you buy for $1,000 or so will have 8 billion the performance of a computer of the same price, okay, inflation adjusted 50 years ago. Do you think you can buy a computer 50 years ago even without inflation adjusting for $1,000? No. Such a thing did not exist. Okay? So that really shows you how fast computers are and how fast they're going these days. Many people have predicted this cannot hold up, right now because computers are already so fast. We cannot keep doubling the processing speed every 18 months. And guess what? It is still going at that pace. Okay? I can personally attest to it because I have a Q6600, a quad-core processor from the Core 2 family on my desktop computer, which at the time was really super duper. It was fast. It was, it's really handy. But guess what? If I get an i7-950 today, which is about the same price as what I paid for my Q6600, it has twice the processing power. Okay, the benchmark is exactly double that of my processor on my desktop. So it is still going at that pace, doubling every 18 months. Okay, so that's great. This is good for us because we can buy faster computers, every 18 months for the same price. The opposite side, which is basically software or programming, that has not changed over the past 50 years. Now, new languages are invented. Okay, we started off with assembly language programming, then we have Fortran, and then we have C, and these days we have Python, we have Perl, we have all these different scripting languages, but that's really just a dialect. Okay, when you think about it, a programming language is a dialect so that you can tell the computer what to do. All these different languages are just different dialects, different languages. You're talking about Spanish versus Portuguese. You're talking about English versus German. You're talking about Japanese versus Chinese. But the way you think, okay, different nationality, different mother tongue, the way people think are pretty much the same regardless of what language you use to communicate with the next person. It's the same thing with programming. So the concepts of programming have not changed at all within 50 years. Okay? And this is all thanks to the pioneer of computer science. Does someone know who is considered the father of computer science? No, Bill Gates got rich. Yes. Okay, I can give you guys, this is definitely out of the scope of this class, but his name is called Alan Turing. And Wikipedia has a very, very good write-up on Alan Turing. Basically, his childhood, everything all the way up to how he died. Okay, he died in his he died early in his 40s, I think. And if he did not die that early, he would have been able to contribute even more to the field of computer science. I believe PBS has also a, is it Nova? I cannot remember which part of PBS had a production on computer science, how they use computers to decipher encrypted messages, and Alan Turing's role in that computer. But he is really considered the father of computer science. Okay, but since him, nothing or very little has changed. Okay, so that's basically the current state of computer science. Now, in this class, we don't really care much about the hardware of computers. We only care about the algorithm, which is related to the software side of computers. Hardware is easy to see because it is physical. Okay, you can hurt someone if you throw a computer at somebody else. What happens when you throw software at somebody else? Nothing happens, right? I mean, software is not a physical thing. You can probably infect someone's computer. That's software. Okay? So software can still hurt, but not in a physical way. Unless the software infects the computer to end up doing physical damage. Okay? Now you can see that I'm just digressing. That's the way my brain works. It just kind of brings up all these different topics. When they're slightly related to something that I'm talking about. Have you guys heard about the Stuxnet virus? No? Some of you have? Okay. It's a very interesting virus. Okay. It's called Stuxnet. S-T-U-X, Stuxnet, N-E-T. Stuxnet virus. It was first discovered, or at least, according to most sources, it was first discovered by the Iranians. Okay? It was discovered by the Iranians in their nuclear plant. Now, this virus is not your usual virus. What do you think a normal virus would do when it successfully infects a computer? It crashes the computer. It might steal data from you. It might turn your computer into a zombie. Basically, a zombie is a computer that can be remotely controlled by criminal elements, so that they can use your computer to launch attacks on other computers. Okay, a virus can install additional spyware, spamware, and all the other nasty stuff that you normally associate with malware, malicious software. This one did not do any of that. This one looked for specific software. I can't remember the name of the software it's trying to find, but it was specifically trying to find industrial control application programs installed on a desktop machine. So we are talking about programs that typically will be used to run a plant, a factory, a manufacturing plant, or in this case, a nuclear plant. Okay? So it specifically looked for a nuclear plant control program. And it's not just going to infect and take over control of that program. It's using that program to send out reprogramming code to what we call PLCs. Okay, PLC stands for Programmable Logic Controllers. Those are the tiny little devices that you actually put next to a coolant line or next to a ventilation system and whatnot. So they are the ones that actually control the electrical devices in a plant, a nuclear plant, a manufacturing plant, and whatnot. So this particular virus was trying to shut down a nuclear plant.
Didn't it do it with the centrifuges? It made them. I forgot completely.
I think that was the attempt.
Yeah.
Okay, the attempt was to shut down the nuclear plant, and I'm not sure whether it's supposed to even damage the nuclear plant, like cause a meltdown in the process.
Yeah.
It was.
No, I don't think it was. I think it was meant to just shut it down so it's not operational.
Okay.
It actually, I think it sent out a signal so that everything looked like it was working fine, but nothing was actually doing anything. So it was kind of like they used bank robberies where you put up a dummy video feed that
Right.
would show the robbers robbing. And so, the programmers, the people at the engineers saw everything was normal, and while nothing was working at all.
Yeah. Yeah, but it was attempting to reprogram the actual PLCs and not just the desktop computer itself. In other words, this entire thing was engineered and designed, specifically for nuclear plants. It was not targeting normal computers. It was targeting specifically nuclear plant control systems. Okay, so in that case, when you hurl this kind of software at a particular target, physical harm can actually happen, like a meltdown or explosion can actually happen. So software can be just as dangerous these days as any weapon, if not more. How much does it take to launch an ICBM? Do you think other countries will pay attention when an ICBM is launched? Sure, right? I mean, everyone will see that launching. ICBM stands for Intercontinental Ballistic Missile, okay, which is nasty stuff. But when you launch a software attack, do you think other countries will notice? Not until it's way too late. Okay? So that's why cyber warfare is actually now on the top list of many countries. Okay, the United States included. Okay, but the United States is a little bit behind the curve right now. They're playing catch up right now.
Who's on top then? Who's on top?
I would say some other countries, that I would not name, because in that case I will be It will be an accusation based on observation, so there's no solid proof of any kind. But I can tell you this much. China, if you look at China, the central government and all its military branches, they do not use Windows. They use their own variant of BSD, Berkeley System Distribution. And BSD is a very secure operating system to start with, and they make additional modifications to BSD, and that's their official operating system for the military and also all the high priority top secret operations. Okay, so if you ask me, I think they were preparing, so that they can defend against attacks from other countries. So I can at least say this much: I think they are aware of the potential, and they already, they have started in year 2000 to defend against, these offenses. Okay, but it's not
doing anything offensively. Purely.
Well, we don't know. I mean, someone can make an attack to appear to launch from China, but it can originate from yet another country. So when it comes to this sort of thing, unless you have actual access to the forensic data, it's really hard to come to any conclusion. Someone sitting in a net cafe in Thailand can bounce off multiple countries to launch an attack. So there's no way to tell the actual place of origin of an attack, unless you can do a lot of those tracking, and those other countries are cooperating with you. But there are many, and it's not even limited to countries. Think about it. There are organizations that are not exactly countries on their own, and they can still be hostile to specific countries. And those people, okay, let me ask you this. How much resources, planning, and coordination do you think it required for 911 to happen? A few phone calls? No. That thing required a lot of coordination. Okay, and if any one of those steps was exposed, the entire operation has to be aborted. What about cyber attack? How much is involved? Not nearly as much. Okay, they can do it somewhere else. They don't need to involve a lot of people. What is the cost of a cyber attack? Do they have to buy expensive stuff? No, it's just a computer and a bunch of smart people. Right? So it is dangerous. Okay? California is now in the process of converting our power grid from the dumb power grid that we had to what we call a smart power grid. What do you think is behind a smart power grid? Little magical creatures, who are, flipping the switches to make sure power distribution is good, right?
Yeah.
Okay? So what is the potential, danger of a smart power grid? Those little magical beings can go crazy, right?
Yeah. Brainwash.
Yep. And a power grid failure can actually cause more damage than 9/11 when it comes to the. If you look at the cost in terms of dollars, it can be more expensive. Okay, so that really opens up, a good discussion of what would be a good career these days. If you're going with computer science, with programming and all that stuff, and you're looking into the future and say, okay, what kind of job should I get? Okay, if you're just doing application programming, that can be outsourced. Okay, companies will set up a branch in another country where labor is cheap, and and they move the entire operation offshore. What about computer security? That's one of the things they cannot offshore. Okay, that's one of those things where they have to keep inside inside the country, and have good clearance, people with clearance to work on those projects. And do you think those jobs will be disappearing anytime soon?
No.
Will there be an increase of those jobs?
Guaranteed.
It can only increase. There's no way it can decrease. Okay, so if you think about jobs, think about computer security, because that's one growing area that will not come back down. The number of computer security experts, will only be more. We will need more and more of those people. The military, all 4 branches of the military actually now has their own cyber division, Is that true? Do you know for sure? No?
I pulled the trigger.
Yeah, but even the trigger, when you pull the trigger, there may be software involved.
Yeah, I've seen some new guns that have come out that are pretty cool.
They have is it a rocket launcher or a grenade launcher?
Yeah.
They have programmable grenades. Okay, so we are talking about grenades that are smart. Okay, you can a soldier can program a grenade. They have a rangefinder thing. Rangefinders are inexpensive. You can go to Home Depot and pick up one for $100 or so. So what they do is they integrate the rangefinder with a grenade launcher, and they can tell the grenade and say, I want you to explode like a meter behind this distance or ahead of this distance or right at that distance. Okay, so now the actual damage by the grenade can be controlled by the soldier who's firing it. Now, of course, it also brings up all the unpleasant stuff related to software, like software maintenance. The last thing you want is it pops up on the screen and say, "Update required" when you pull the trigger, right? Your system is now infected. Please shut down. Then you can just throw that whole thing. Yeah, just make sure it's not powered by Microsoft. Mm-hmm. Sorry?
Said it makes a good club.
Yeah, kind of heavy and not very effective. A nailed board would work better in that case. All right. Well, that means software is very, very important. I mean, with all this discussion, don't you guys think that software is important? Okay. So that's why I have this little sentence here. Even with the best available hardware, a computer is nothing more than a heater without proper software. Okay, and they're not even good heaters anymore. I miss those good old days when you have a first Pentium processor or Pentium 4 processor. That makes a good heater. These new processors, they don't even get warm most of the time. So what is software? Okay, the essence of software, if I skip this entire paragraph, is it is the specification of how processors in a computer should operate. Okay, because a processor can do many things. Okay, the hardware can add, it can subtract, it can compare, it can say, oh, I want to go to here to continue execution. But unless those operations are performed in a specific order, the computer will be doing something that is useless. So the usefulness of a computer is to perform the operations that the hardware can perform, but in a meaningful way, in a meaningful order. So software is the specification of that order. What instruction to execute, and then what instruction, and then what instruction, and so on. So that basically covers the next paragraph here. Okay, your processor, even the Pentium processors, cannot do complicated operations. All they can do are very simple arithmetic stuff and comparing and logic stuff. Okay, all the complicated software that you see is a combination of billions and billions and billions of these instructions. And software is everywhere. Computers are everywhere, and as a result, software is everywhere as well. Right here in this classroom, I will be guessing that we have around 60 computers right here. Okay? Because, well, we have the obvious one, which is this one. And then we have the not so obvious one, which is your smartphone. And then we have your ebook reader. Who else has an iPod and MP3 player? That's a computer right there. Okay? So we probably have about 60 computers because one person may have a smartphone and an MP3 player, or a smartphone and an ebook reader. So one person actually can carry multiple computers already, even without knowing it, okay? Or not being aware that you have been using multiple computers. How would you call this? Most people call this a smartphone, right? I mean, it's an Android-powered phone, and it is normally called by the market as a smartphone. I would call this a computer pretending to be a phone. It's a poser. Okay?
it's a computer that lets you make phone calls.
Because it is more of a computer than a phone. In fact, I would say that this is a better computer than this one here. Now, let me explain why I say that. This has GPS. This does not have GPS. This one has a compass. This one does not have a compass. This one has a microphone built into it. This one does not. This one has Bluetooth built into it. This one does not. Okay? So the list just goes on and on and on. The desktop has a few things that is on its side. Okay, that, it has more storage, it has more processing power, has more RAM. In other words, it has a lot more brute force. But when it comes to devices or what you can do with it, your cell phone can actually do more. Okay? Are you guys now convinced that when you look at a desktop computer, that's really a very archaic, a very ancient design. Your cell phone, your mobile device is the way to go. Okay, everything is going to become smaller. They will have more devices built into it. I mean, this one has a camera, and this one does not. I mean, it's just if you think about it, and this is $100 from Walmart. So that gives you an idea of the future of software development. If you want to get rich really fast, what do you do? Legally. Well, if you think about illegally, would anyone rob a bank seriously these days? Why would anyone rob a bank physically?
Electronically.
No, they want to be caught and be thrown in jail.
Yeah.
Okay? 3 meals a day, shelter and all that stuff, that would be the only reason why someone will run to rob a bank to get rich fast. If you want to get rich fast, you take a class like this, you take a C programming class and a Java programming class, and then you write your iPhone or Android apps. Okay? Has anyone heard of the app called Angry Birds?
Yeah.
Okay? That has become the major export of its country of origin. What is the origin of Angry Birds? It's one of those, northern, European countries. It's either Norway or Sweden. Yep.
Did you hear just like the other day, a 14-year-old kids program out surpassed Angry Birds as the #1 free iPhone?
Oh, really?
Yeah.
No.
Yes, it's top on the list actually in the market right now.
Which one?
In your market area where you go to pick your apps out, it's like the very first one on the list. Angry Birds is.
Angry Birds.
Uh-huh.
But someone said, a 14-year-old just beat it.
Oh, really?
Yeah.
Well, of course, it's going to be a 14.
Yeah, but I think Angry Birds became the major export of that entire country. Okay, this is bringing in more money from outside the country. It becomes the main quote unquote export of this country. But I cannot remember which country. It's one of those countries really, really up north.
Finland. It said it in the Wikipedia page, Finland.
It's Finland?
Yeah.
Okay. So I guess Finland does not have a whole lot of other exports, and this is now their main income. This is where they get money into the country. But it does give you an idea. I mean, how many millions have they made so far?
Significant amount.
Significant amount, okay? And it was over a very short amount of time. Okay? So if anyone wants to get rich really, really fast and you think you have a really good idea, take programming classes or get someone else to write your apps. Okay? I was contacted by a young person and said, Tech, I have a really good idea. Why don't you, write the apps, for me, and we'll all get rich fast. Well, I don't know. I have my day job, so I'm not really interested in making millions in a few days. So, I mean, what would you do if you make millions of dollars in a few days? I mean, then you don't have to work. Then what do you do with your time? Write more apps? Anything you want. That's the problem. I think people die faster that way, so.
That's actually pretty true, I think. People don't get retired. They don't find much to do.
Over 12 million copies of the game have been purchased from Apple's App Store.
Now it's free.
Is it free now?
It's free in my phone.
It's free on Android.
Hmm?
Yeah.
On Android, it's free.
Oh, and on Android it's
They
free?
have ads on it to make money. But
Over
the other-
15 million across all platforms.
The other
That's-
game, the other game's called Bubble Ball. Is the new.
The
top
Bubble
Android.
Ball
Top.
on the top list.
Yeah.
Now, what you guys need to understand is, Bill Gates is a rich man, okay? But it took him how many years to get this rich? Decades, okay? Decades. It's still fast, okay? But it took him decades to build up Microsoft the way it is now. And these kids, people who develop these software, got rich literally over days. Okay? If you count the development time and the planning time, at the most, months. Okay? So that's the way things are going these days. Okay? How come we don't have anything quite like this, before, iPods, iPhones, and the Android? When we only have desktop computers, how many desktop computers do we have as opposed to how many smartphones do we have? Okay, that's the reason. Okay, that's the reason why once you have iPhones and also Android, writing apps on these mobile devices suddenly becomes a big thing. Okay, so this is also something that you might want to keep an eye on, not only to make a lot of money in a very short amount of time, but also think of the potentials. All kinds of different software that you can write on a cell phone. Okay, I can give you an idea. On this cell phone here, I can probably write an app that will be of some interest to, say, insurance companies. Okay, you can make a mount, so you can mount your cell phone on the dashboard with the camera facing forward. Okay, so when you drive, your cell phone will be recording your GPS location, your speed, what you're seeing on the front. It will also record all the information about vibrations. So in case of an accident, okay, in case of an accident, your phone can record how you were hit by the other car. Hitting from the side, from behind, exactly what is the vector of the collision. Okay, the car behind you was hitting right from behind or at an angle. How fast? Okay, how long was the duration of the collision? Okay. So all that information as raw data can be collected by your phone because your phone has all the hardware to record that information already. It's already on your phone. What is missing is an app. Okay? What is missing is an app that will collect all that information and upload it to a server instantly. So that way, in an accident, if your phone is destroyed in the process, it would still be able to upload as much as it could before it is physically destroyed. Okay, and I can see insurance companies, maybe not for consumers, but insurance companies for truckers, can potentially use that, to help out in case of disputes and whatnot. Okay, now obviously, someone's not going to make millions of dollars over a few days with an app like this, but nonetheless, there's a market for apps like that.
Not just truckers though, that'd be like something that any company car they'd want.
Yeah.
Any
Track
fleet,
your-
yeah,
you could
any
track
fleet.
your employees.
Yeah, they probably have something
They
like that
They
already.
already have LoJack. They already track their employees and where they go, but they don't have anything like that.
Yeah, but not visually.
Yeah.
Yep. Well, many phones now have two cameras instead of one,
Yeah, front and back.
front and back. So you can capture, your phone can capture a lot of information, whether you know it or not. And that's why I get bothered when people talk on the phone when they walk into the bathroom. I just it just sends shiver up my spine because guess what, my camera is facing out like this. And they're talking when they walk into the bathroom. It's
exactly.
Yeah, that bothers me a lot. So on this slide, I only gave some really old and kind of boring examples. Cell phones is one. The ECU of your car is another one. when you drive a car, okay, let's say you're driving a somewhat of an econo box like a Toyota Corolla or something like that, that car probably has between I would guess somewhere between 6 to 10 computers on it, specialized computers, because you need one computer for the ECU. The ECU stands for Engine Control Unit. There's no screen to this computer. There's no keyboard to this computer. There's no touch screen to this computer, because this computer is is taking input from what?
Oxygen sensors, mass
Oxygen,
air.
exactly. Oxygen sensor, mass air sensor, NOx sensor.
The timing sensor and also the heat of the engine.
Yep, maybe temperature sensor for the air and stuff like that. And it will use that information to make decisions. And what does it control? It will control at least two things related to an engine. One is the fuel injector, how much fuel to inject, when to inject, and when to ignite that inside the cylinders. Okay, and this is one specialized computer. The other specialized computer on just about any car these days is the ABS computer, the anti-lock brake system computer. I believe ABS is now mandatory. Someone can correct me if I'm wrong. Is it mandatory now?
It is.
Okay, and it's a good thing, because ABS does save lives. It does not really avoid accidents all the time. In other words, how fast you can slow down with a car is entirely determined by the compound on your tires, as well as the surface of the road. Okay, you cannot cheat physics, unless you have a retro rocket or something like that on your car. Then you can actually decelerate at a very, very high speed. But then your rocket may explode sometimes, so that can be dangerous too. But ABS cannot, it cannot make the braking power any more than what physically is possible. But what it does buy you is a decision. Okay, you know that you cannot slow down fast enough. You know you're going to hit something, but you can choose what to hit. Would you fall off the cliff, or would you hit the back of the other car, or would you you have choices, okay, with ABS. Without ABS, you don't have a choice. You slam on the brakes, the car just kind of goes with its own mind. Okay, so anti-lock brakes is implemented by computers, and I think in the near future they will also have stability control will also be mandatory. So that's also computer based. Okay, the computer will basically monitor all four wheels at the same time, and it will try to correct oversteering as well as understeering by braking one side of your car, by braking one tire or one wheel of all out of four, by decelerating, controlling the gas or the throttle, and so on and so forth. It will try to make your car go where it is pointed instead of understeering or oversteering, and that's going to be controlled by computers as well. Okay. Now, if you think about it, with all these computers controlling all these important, really important functions of a car, don't you think software, or the integrity of software is going to become important? Ask Toyota. Okay. Now, Toyota only had an accelerator problem, okay, which is actually not as dangerous, because with an accelerator problem, the one thing you can do is to turn off the ignition. Okay, unless you have a diesel engine, then you are kind of stuck. With a diesel engine, you turn off the ignition, but wait, there's no such thing as ignition. You have to cut off the fuel in the case of a diesel engine. Someone told me, and I'm definitely digressing here. Someone told me that with a diesel engine, someone tried to cut off the fuel, but could not find the fuel line. So the next thing was to try to cut off the air, because combustion needs both fuel and air to start the process. So someone was trying to cover up the intake, except the engine was so big and so powerful, it just sucked the big piece of cloth into the engine in the process.
That's one way to get it.
Yeah, that's one way to kill the engine, except it would be kind of difficult to start it up again. So this slide is not, it's just here to show you, it shows you that computers are now everywhere, and every computer needs software. So if you think about it, the job opportunity for software development should be pretty good, okay? Because we are seeing more and more applications of for software. There's even a software application on a wrench, like a wrench that you use to fix a car. Can someone tell me why do I want software running on the wrench?
Pounds of pressure.
Using like a torque wrench, you can set it to a certain rating, and then you torque it.
Or an adjustable wrench can be automatically adjusted or something. I don't know.
Yep. But the torque wrench thing is already there. If you go to the Snap-on website for car mechanics, they do have wrenches with computers on it, so they can actually preset a torque amount. It can either give you some feedback or display on the screen how much torque is actually being applied. Okay, and that can be useful. You can also do the same thing with hammers. Okay, when you strike a nail or something like that, it can tell you how hard you're striking the object. Okay, so lots and lots of applications for software because computers are now everywhere. So now we start to talk about the people who are going to write these software. The people who are writing the software are typically called developers. Computer scientists refer to people who do more of a research-oriented work and not just writing the programs. The people who are writing the programs are typically just called developers. We also call those people programmers and coders from time to time. This is also a good time to not digress so much, but to point out a separate resource. It is the Bureau of Labor Statistics of the government. BLS? Yep, the Bureau of Labor Statistics. And they keep track of a lot of interesting data as well as projections. So the one thing that I want to give you guys at least an exposure to is occupational outlook. And this is a quarterly. Let me see if that's the one. That's not the one that I want to look at. Database, subject area. This one, they do outlook, job outlook analysis, employment projections. Sorry?
The one right below it, maybe?
Job openings, labor turnover. I think it's employment projection.
You're looking for the occupational handbook?
Yep, right here.
I think it's under the.
I got it.
Okay.
Yep, it's right that link. And it separates everything into management, professional, and so on. Computer and mathematical is one big category. And let me just make it bigger. Under this category, they have computer and mathematical occupations. So now you have all these different occupations related to computer science or programming, and you can look it up to basically look at the projection of employment over the next. Let's just pick on one. Let's pick computer programmer and software engineers because that's basically what this class is about. And they will show you nature of the work, job outlook, and right here, employment of computer software engineers, which is a super programmer, if you will, is expected to increase by 32% over the 10-year period from 2008 to 2018, which is much faster than the average for all occupations. Okay? You can also look at the salary range. Okay, how much money can you expect to make when you get out there as a software engineer? So you go to earnings and wages, and they separate it into different categories. In this case, we'll look at computer programmers. Yep.
What's the difference between a programmer and a software engineer?
That's a good question. I'll answer that question, when we kind of come back from this one. So right here it says, the mean annual wage is $75,000 or so, and they also give you a breakdown of percentile. In other words, at the 90 percentile, programmers can make up to $113,000 per year. The median is $70,000, and at the low end, the lowest 10% will make about $40,000. Okay, but the point is, there will be a lot of jobs. Okay, having a job is better than not having a job. And to answer your question, a software engineer, would do what a programmer would do, but on top of that, a software engineer will also involve in the design process. So it's not just coding, but also designing the overall system itself. Okay? So there's more engineering or more design work involved when it comes to a software engineer, but a programmer typically will just write the programs to implement the logic that somebody else has already specified. In other words, if you have a choice, you want to become a software engineer and not a programmer. Okay. Is that helpful? I mean, is this information kind of relevant? Okay. This is also a good time to do a quick survey because when I taught this class in the past few years, I have always assumed everybody in the class is on the track to a computer science or computer engineering track. But I have learned that that is not true. So I would just start with asking who is on a track to some engineering discipline like electrical, mechanical, civil. Okay, so this is actually a higher percentage than normal because I typically have about 5 or 6 students in the class who are on an engineering track, who are on a computer science track. So that would be the other half of the other majority of the class. What about the rest? Who is on a mathematics track? Okay, and
I'm a geographic information systems
GIS.
analyst. Yeah.
Okay, now GIS has a very interesting range of programming. It can go from customizing just the user interface all the way to database stuff and all the way to programming stuff. So that's an interesting application of programming. Very good. And besides the developer, besides people who are actually writing the software, there are also other people involved when you write programs or when you develop a whole system. The first type of people will be the systems analyst. The developers are kind of sandwiched between systems analysts and the test engineers. And this section is only here to give you guys a context. So when you do come out to become a programmer or a software engineer, you kind of know how you fit in the bigger picture. The systems analyst, okay, I usually do this with an analogy. So let's just say that you have acquired a piece of land that is next to a cliff, or the cliff is included in your property next to the ocean, okay, the Pacific Ocean, with a great view. Okay, it was given to you, and now you want to build a house because you are sick and tired of tenting on your property. Okay, which is great for the first few days, but when winter comes and if the storm is here, living in a tent is not as attractive anymore. So you want to build a house on your property, and it's really nice. How do you go about building a house? You start with a foundation, but would you do it yourself? Okay, let's say you have money. Okay, someone gave you the land and also money to hire people to do it. So what would be the first type of people to hire when you want to build a house? An architect. Okay, an architect first. What is the job of an architect? Design. Very good. Designing to whose criteria?
The purchase.
The clients.
Yes.
Okay, very good. And that's part of the job of a systems analyst. In other words, when a client, let's say a bank, wants to implement a new information system, they would basically talk to a systems analyst first, or multiple systems analysts, and tell the systems analyst, okay, I want this information system to accomplish these objectives, like increasing work efficiency, accuracy, or for legal protection. Okay, we want to make sure we do everything to code, so that we can avoid lawsuits and stuff like that. So all of these criteria will be given to the systems analyst. when you're building a house like that, what would be some of the criteria or requirements that you will convey to your architect?
Safety standards.
Safety standards, okay, but the safety standards, will be mostly enforced anyway by, city code, and, the civil engineer will enforce that part too. But what about the layout of
Yeah,
your
where you
house?
want your bedroom.
Where you want your bedroom? Okay, I want my master bedroom to face the ocean and have a 180-degree view of the ocean. Okay, maybe that's one of your criteria. Maybe you want both the living room and the bedroom to face the ocean, one on the first floor, one on the second floor. Okay, so that stuff, you have to tell your architect, and you leave it up to the architect to actually come up with a design. Okay, and it's the same thing with an information system. The client will tell the systems analyst all the requirements, all the criteria, and then the systems analyst will design the system as a whole. What is the next stage when you build a house? The architect comes back with a design, on a blueprint with all those nice little pictures, and a 3D model of everything, and you say, okay, that's exactly what I want. Okay, what is the next stage? That's one thing before the contractor.
Materials.
Materials, not yet.
Permits.
Not yet. Not. There's one thing before that. There's one more person involved in the process. A civil engineer. Okay? What is the job of a civil engineer in the process of building a house? An architect is a designer. Okay? They come up with really nice design, pleasing to the eyes and yet functional in the inside and stuff like that. What is the job of a civil engineer?
Make sure it meets safety standards.
Yep, exactly. They will analyze the soil type to make sure that the soil type right next to the cliff can support the house. Maybe one of your criteria or one of your requirement is, I want half of the house to extend out of the cliff. And I want the first floor to have a transparent base. So I can walk out there and I can look down and I will be looking off the cliff. Okay? Well, it's possible these days with all the materials that we have. Okay? The architect will have no problem. The architect will say, okay, I can design it. I can specify the floor of your first floor will be transparent along with all the windows. So now when you walk outside, basically you will be walking in quote unquote free air, and you can enjoy the entire view, and not just what type of material you will need to build a house. Okay, he would have to analyze what happens, when you have winds up to 80 miles per hour, coming in different directions to hit the house. Would the house still be there after the storm? Okay, so that's the job of a civil engineer, not to design, but to verify the design is safe and it can actually be done. In this case, the systems analyst will also double as a civil engineer. In other words, a systems analyst will both be the architect to design the system as well as the civil engineer to make sure the design is feasible. It can actually be done. Okay? When that is all done, they go back to the client and say, okay, it can be done, this is the design, this is how much it will cost. The client says, okay, everything is good. Then the next stage is to build the house. Now, when you build a house, would you ask the architect and the civil engineer to pick up their trucks and tools and, okay, now we can start building the house? Probably not. Okay, so who's going to build a house once you have the blueprint, everything is calculated, it's all good?
Carpenters.
You have contractors. Okay. Generally speaking, we just collectively call those people contractors. Why don't we ask the architect to build a house? Why don't we ask the civil engineer to build a house? Let's just say that you have the money to say, okay, guys, I really like your work so far. I want you to build a house. I know it's going to be expensive. That's not a problem for me. But it's a problem for the architect. It's a problem for the civil engineer. Why is it a problem?
That's not what they do.
That's not what they do. It's not what they are good at. Okay? It's the same thing in when you build an information system, because a systems analyst typically has job responsibilities that will make them not very good developers. Okay, so certain aspects of the job of a systems analyst prevent them from being good programmers or developers. So let's go to the developer slide and take a look at some of the challenges of being a developer. I'm going to skip the first part here. So we'll go to the major challenges in program development, actually writing the programs. The first obstacle has to do with syntax, okay, the syntax of a programming language. In other words, where do I put a semicolon? Do I need a semicolon at the end of every line? Maybe, maybe not. Do I use a comma here, or should I use a semicolon here? Okay. What type of parentheses should I use? Should I use the round ones or the square brackets? Okay, so all those things fall into the category of syntax or the grammar of programming languages. But that's really not a very big obstacle to most people. You just have to use a programming language long enough, then it will all be somewhat natural. It's not a main obstacle for most people. The second part has to do with the logic of a program. Now, someone can argue and say a systems analyst also has to do with the logic of an information system, except a systems analyst only has to do with high-level logic and not the really detail of implementing the logic. For instance, the systems analyst can specify, well, for security purposes, if a client tries to log in 3 consecutive times and all 3 times use the wrong password, lock the account out. Okay? So that's the extent of the logic that a systems analyst has to specify. Now, when you think about the actual implementation of that logic in program code, it's not that simple anymore. Because now the programmer has to think about, okay, so we need to keep track of how many times the customer has failed to log in. How do I do it? Okay, do I use a database? Do I use this mechanism? Do I use the other mechanism to keep track of that? Okay, the programmer also has to factor in a lot of different things, like what if the client is trying to log in from the internet? What if the client is trying to log in from inside a branch? Okay, do I give these things? Do I give different considerations depending on where the client is trying to log in? The programmer has to do with the language itself. Okay, should I implement this in this language or in that other language? Even in a particular programming language, there are multiple ways to implement the same thing. In other words, the programmer has to deal with a lot more details to implement that logic that was really easy to specify from the perspective of the systems analyst. Okay, am I making sense so far? Yeah. Now, when you have that much details to deal with, okay, and everything has to be very specific because a programming language is very specific. You miss a semicolon, it's not going to work. You miss, a period, it's not going to work. You miss, you use the wrong parentheses, it's not going to work. So with all these details to take care of, it is no wonder that most programmers do not want to be bothered. Okay? If you look at the personalities of a typical systems analyst, and you look at the personalities of a typical programmer, a systems analyst is a people person. Because for the most part, a systems analyst has to talk to the client, to find out what the client wants, to interact with the client. Okay, you said that this is not exactly what you want, but can you tell me, how it is not, meeting your goals? Maybe I'm misinterpreting some of your original statements and so on and so forth. So a systems analyst has to deal with people a whole lot. Okay, but a programmer, on the other hand, has to deal with the details. Everything is rule-based. It has to be very exact, and so the personality traits are different. A systems analyst, can say, okay, I'm done with the meeting today. I have written all the documents that I'm supposed to write. I will call it a day. Everything can wait until tomorrow. Okay? A programmer can be on the way to write a particular piece of a program. And it's 5 p.m., and the program is not done. Okay? you can't, as a programmer, you cannot just put it down and say, I will pick it up tomorrow in the morning. Why not? Exactly. There's your brain at that point when you're writing a program, in the middle of writing a program, your brain, your mind is keeping track of a lot of little details, as the context of doing your programming. Okay? If you put it down at that time and start it up tomorrow in the morning, most of that context will be lost. So you'll probably have to spend half an hour to reestablish all that context in your brain or in your mind in order to continue the work. So it is very tempting for programmers just to keep working, basically just keep working until the whole piece is done. And that's why when you watch television shows and movies and whatnot, all those geeks and nerds and whatnot, they work until midnight. They don't really care when the sun sets. Okay, is that kind of meeting your kind of typical view of a programmer? Okay. When I was a programmer, when I was a developer, I still am. A lot of times, I would start working at 11 p.m. because that's when my kids go to sleep and I have everything else done in the house, and I can actually sit down without any disruption to start to work. And a lot of times, when I'm all done, the sun is rising already. I would have missed a lot of time and not realized that hours have passed already because I'm just absorbed in the work. Okay. A systems analyst. Okay, do you think a systems analyst will get a lot of email, phone calls, faxes, and stuff like that? Yeah.
They're the go-between.
Yep, they're the go-betweens.
Yeah.
Do you think a programmer would appreciate, phone calls from friends and like, how are you doing?
No.
No.
Yeah.
Go away, I'm programming.
Yeah.
So that tells you something about, the job or the nature of the job of a programmer as opposed to the nature of the job of a systems analyst. The most challenging part of being a programmer is not writing new programs or writing new code. The most challenging part is about debugging. Okay? What is a bug in the context of programming? Something does not work right. Well, I'll call it a defect. Okay? Just a defect or a deviation from what the program is supposed to do. Your program may not be crashing. It may not be hanging. It's just not doing what it is supposed to do. That's called a defect or a bug. To debug a program means to find out why the program is not behaving the way it's supposed to and fix it. Okay? And that's the most challenging part of being a programmer. It's like being a car mechanic. Okay? When you think about the job as a car mechanic, changing tires is not very difficult, at least in the mind, because it's not challenging. Okay, you just have to follow a few steps, do it right, and it can be done every single time. If you think about changing oil, okay, it's not really that challenging because it's just a matter of finding the drain plug, okay, finding the oil filter itself, doing the work, keeping yourself clean, hopefully almost clean, mostly clean the whole process, and that's it. The most challenging part of being a car mechanic is diagnosis. Okay? The car won't start. Why isn't it starting? So now you have to go through, a train of thought, logically go through all the steps. Okay? In order for a car to start, it needs to have all of these things, present. So now you have to check it off one by one. The customer may give you some clues. Okay? Well, the engine turned, but it did not start. So now you know the battery is probably good. Okay, you can double check it. You probably know that the starter motor is good. Okay, so maybe fuel is not delivered to the engine. Okay, maybe it doesn't have the right fuel air mixture. Okay, maybe there's no spark. Okay, maybe the spark plug cable, the ignition wire is frayed, so there's no spark in the engine. So you have to go through these steps logically, step by step, And as you confirm, have some observations, then you start new ones, okay? And then you say, okay, we know the spark plugs are good, and that's spark. So now what can be missing? Well, maybe, there's not enough, fuel. So you have to check the fuel lines and stuff like that. Well, okay, there's no fuel. I confirm there's no fuel. Why is there no fuel? Is the fuel pump the problem, or is the fuel filter itself clogged up? Because both of these can cause problems, with the same symptom. So you have to work like this when you're programming, when you're debugging a program. Except when you're debugging a program, you cannot see stuff. It's not physical. Because everything is logical. Your program is just a long description of what the hardware is supposed to do. So when you're debugging a program, you cannot rely on visual inspection. There's no visual inspection of any kind. And a lot of times when the program misbehaves, it doesn't really leave behind a lot of clues that you can start with in order to diagnose the problem. So debugging turns out to be the most challenging part of being a programmer. Do you think a systems analyst needs to debug anything or diagnose problems like this? Nope. It's just like an architect doesn't have to fix a leak in your kitchen. Okay? Well, let's say that house was built. The house, right next to the cliff was actually built, and you start living in a house, and the second year, it started to leak. Who do you call? Do you call the architect and say, hey, the house is leaking, come fix it? No, you don't call the architect. How about the civil engineer? No. What do you call? Who do you call?
Contractors.
The contractors. Okay, the contractors get to your house. They can actually see the water stain, from your ceiling, and now they have to find where the leak actually is. Okay, so that's why being a developer also needs to have all this logic, in order to find out where the problems are, and believe me, this requires a certain types of personality. A certain type of personality. Do you think a person with a temper this big and a fuse this short would be a good programmer?
No.
Do you think Mike Tyson would be a good programmer? I mean, the computer doesn't have any ears.
Yeah.
No? So a programmer needs to remain calm most of the time. Okay? It's not like you cannot get frustrated. I get frustrated sometimes, but I don't take out my frustration by destroying the keyboard or the mouse or throwing my monitor around. I just, kind of, for the most part, I don't even get frustrated, okay? If there's a problem persisting, in my mind, I just kind of go through and go like, okay, I'm pretty sure I went through all these steps, so I can confirm these things I've checked and they are not a part of the problem. What else have I missed, okay? Did I miss something? So I will just keep doing that, and when you are on a track like this, you don't have time or energy to get frustrated because you're so focused on just the logic to find out what the problem is instead of getting frustrated that there is a problem. Okay? In my previous job, I kind of erased the timeline. In my previous job, there was one time that one of our products delivered, the entire line of product had a problem. Okay? They changed the chip, and somehow with a new chip, the entire batch of product would not work, for certain things. So certain functionality would not work. Okay? So it's a big liability because now we have these products actually delivered to our customers, and they are having problems using the product. The marketing manager was just running around crazy, because he has to answer to all the customers. Because the customers are calling up and saying, the product is not working. What are you guys doing to fix it and stuff like that? And of course, as the one responsible for software, I'm charged with the responsibility to fix that problem, even though I did not write that software. So the marketing manager will come into my cubicle like every hour, every 2 hours or so, and in all the meetings he would ask, when is it going to be done? It has been days already. And in the meetings, of the product meetings, he would also bring that up and say, well, we need it to be done as soon as possible. When can it be done? And my answer to him was, it will be done when it's done. Oh, he just blew up, when he heard that. And I was not even intending to piss him off. I was just saying, there's no way I can actually tell when it can be done because I have no idea. I'm not asked to manufacture 100 of these things, okay? Because in that case, it is somewhat predictable. I'm supposed to fix a problem, and there's no way I can know how long it will take unless I know the nature of the problem. So finally, the sales manager, kind of just stepped up and say, Dan, why don't you just give it a break and let him do what he needs to do? Because by asking tech all these questions and pushing him, you are actually making him work slower.
Yep.
And she was absolutely right. Okay? They should have left me in the office and not bring me to the meeting so I can continue to work on the problems instead of having to answer to these people, tell them an estimate, which I have no idea when the problem can be fixed. Okay? So that means if you want to become a programmer, okay, you do have to have that mindset to focus on the problem and approach it in a very logical way instead of being upset. We all get upset for certain things, but when you're a programmer, you cannot get upset over your program not working the way it is. You can still get upset when someone cuts you off when you're driving. That's okay. Just not when your program is not behaving, because there's nothing you can do. You can curse at your program all day long, it does not respond at all. You can curse at people, it's even worse because it typically worsens the situation. Okay, is that making any sense so far?
Yeah.
So we'll just go ahead and finish this up, and I will give you. Okay, we won't have enough time to finish everything, but this entire module is really just an overview of who writes the software and what an algorithm is. So what I want you to do over this week, because remember we don't meet for the next 6 days, so you do have plenty of time to do your homework, and I also want you to start reading this part here. This is the actual introduction to writing pseudocode. So I want you guys to at least read this particular module before next class, and then we'll talk about the basics of writing a program in pseudocode. So if you have access to Moodle, you can click on this link, and it will just bring up a module like the other one. That's your reading assignment, and your homework assignment that you have to turn in is the other one that I just mentioned. If you're adding to the class, I will call your name. So if you don't want to, come up here and then just be standing around, I can call your name. You can remain seated. If you're already in the class, you can leave the classroom now unless you have a question. I can answer those questions later. And I can stop the recorder.